Welcome to AP Calculus, Definite Integrals Part 3, Acceleration, Velocity, and Distance. Alright, so what have we learned already about acceleration, velocity, and distance? I think we've learned this right here, that the position function is x of t, and that the velocity function is the derivative of the position function, and the acceleration function is the derivative of the velocity function, or the second derivative of the acceleration function. So, going in reverse, would it not be true that the velocity function is the integral of the acceleration function? And other things as well. So here we go. Let's go ahead and look at how this works with given an acceleration function. Example number 1. Alright, go ahead and write all this down, and then we'll start working on the questions. Alright, so I'll give you a second to do that, and I'll pause. Alright, we're back. Hopefully you read this with some words, and you noticed something very important up at the top there, that this begins moving from a standing start up here. That tells you what the initial velocity was. So v of 0 equals 0. Hopefully that will help you as we move along. Alright, so what is the velocity function? Okay, here we go. A. The velocity function equals the integral of 1800 over t plus 20 quantity squared dt. So let's go ahead and use a little bit of substitution. U equals t plus 20. So du equals dt. That's actually a pretty easy substitution, isn't it? But that will simplify the denominator there. So we're going to have v of t equals 1800 times the integral 1 over u squared du. Okay, so that will be 1800. Okay, that's u to the negative 2. Add 1, that would be u to the negative 1, so negative 1 over u plus some constant. And we're going to have to figure out what that constant is. Hold on a minute. Let's go ahead and change back. Okay, v of t equals negative 1800 over t plus 20 plus c. So v of 0 equals negative 1800 over 20 plus c, and we're told that that velocity of v of 0 was 0. So 0 equals negative 90 plus c. So c must equal 90. So our velocity function must equal negative 1800 over the quantity t plus 20 plus 90. There is our acceleration function. No, I'm sorry, our velocity function. Alright, the second question asks us, part B asks us, when will the velocity be equal to 66 feet per second? Alright, so let's see here. We're going to set this equal 66 equals negative 1800 over t plus 20 plus 90. So let's go ahead and subtract 90 from both sides. Negative 24 equals negative 1800 over t plus 20. Okay, t plus 20 times negative 24 equals negative 1800. T plus 20. I don't feel like distributing that out because we can just divide both sides by negative 24. Negative 1800 over negative 24. So t plus 20 equals, hold on a minute, I have to work that out. Alright, I got my handy dandy calculator out. It said 75. Subtract 20 from both sides. T equals 55 seconds. And that's how we're going to play this. Let's go ahead and move on to the next example. Example number 2. Yeah, you've got a little bit of writing to do. Example number 2. I will let you go ahead and write that down. I'm going to walk away for a minute and, well, I'm going to pause it first. So I'll give you as much time as I think you need to write that down, and then we'll talk about answering each one of those questions. Alright, here we go. Alright, now that you've recorded as much as you could, let me move the rest of the question down so you can see what the A, B, C, and D are, because my face was in the way. Alrighty, I'll pause it again. Alright, so let's go ahead and attack this problem. Part A. It's asking for the velocity. So once again, we're going to go v of t equals the integral of a of t, which is 1 over t plus 1 dt. Hopefully by now you guys know that this is like 1 over t. Alright, so that would be the natural log. So v of t equals the ln of t plus 1 plus some arbitrary constant. And your initial value was v of 0 was negative 5. So negative 5 equals ln of 0 plus 1 plus c. So negative 5 equals 0 plus c. C equals negative 5. So the velocity function is the ln, equals the ln of t plus 1 minus 5. There's the velocity function. Alright, what does B ask you? Find the position of the particle at t equals 5. So now they're asking for we're going to have to find out what the position function is. So we're going to have the position function equals the integral of ln of t plus 1 minus 5, all with respect to t. And hopefully by now you guys know what the antiderivative of the natural log is. If you don't, go look it up in your notes. And if you don't want to do that, watch, I'm going to show you. Remember, it was x ln of x minus x. So this is t plus 1. But because of the chain rule, the derivative is 1, so it doesn't change it at all. T plus 1 times the ln of t plus 1 minus t plus 1 in parentheses minus 5t. Let's clean that up just a little bit, please. Whoops, plus some arbitrary constant c. But even before we go into substitute, let's clean it up. t plus 1 times the ln of t plus 1 minus 6t minus 1, whoops, minus 1 plus c. Alright, now we've cleaned that up a little bit. Let's go ahead and we were told that the original position x of 0 equaled 8. So 8 equals 0 plus 1 is 1 times the ln of 1 minus 6 times 0 minus 1 plus c. 8 equals 0 minus 0 minus 1 plus c. So c has to equal 9. So the position function, yeah, this is a lot of work for one problem. I get it. X of t equals t plus 1 times the quantity ln of t plus 1, whoops, minus 6t plus 8 when I put in that 9 right here. So you are told that x of 5, no, you want to find out what x of 5 is. So x of 5, the position function at 5, equals 6 times the ln of 6 minus 30 plus 8. So the x of 5 equals 6 ln of 6 minus 22. So the position at t equals 5 is negative 11.24944. Alright, part C asks you to how far is the particle moved from its position at t equals 5? Alright, they're asking for two different things, the position shift or the displacement. To find the displacement, we are going to take the integral from 5 to 200 of v of t dt. That will find you, from 5 to 200, v of t dt. That will find you how much the position has shifted. So go ahead and put the velocity function into your calculator and find out how much the position has shifted. When you figure that out, put your answer down. Now my answer is 114.78627. I know you got a negative answer there, but it's asking how far has the particle moved. It didn't say whether it moved to the left or to the right, just how much it's moved. It's moved 114.78627 from its original spot at 5 to 200. Okay, part D asks you to find how far did the particle move in that amount of time. And I'm going to tell you that to find how far that distance is moved, you're going to take the integral from 5 to 200 of the absolute value of the velocity of that function over that distance. So you'll have to go find in the math the absolute value and then put in absolute value and then put in v of t to figure it out. Alright, so go ahead and use your calculator and do that. I've only got about 20 seconds left. Come back to look at your answer. And that particle has traveled a distance of 131.54116. Ask me in class about how to differentiate between displacement and total distance traveled. This will end AP Calculus.